is the Amp Hour Podcast, recorded September 26th, 2011. Episode 62, Narquois, Nerd, Nescience.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble from Chris Gamble's Analog Life. Hey,
Chris. There's no one else today. Just us?
Just us.
Bit of a change? Just a regular show?
Yeah, I don't know. This is kind of this isn't the norm anymore, so.
Yeah, right. Yeah, true.
I like it. We might actually get through some articles we have posted or anything. Yeah.
And regular segments. Because everyone loves the regular Amp Hour segments.
Yeah, some people do.
And we'll try our best to fill those bingo sheets for you.
Oh, yeah. Maybe we should open them up and go along and see if we can...
Right, tick them off ourselves. We'll become obsessed.
Yeah.
Ah, boy. So what's been happening on the other side of the ditch?
That's a big ditch, huh? It's filled with water, too.
Yeah, big-ass ditch. Yeah, about, what is it, 10,000 miles or something?
Something like that, yeah. I spent the last week out at MIT, actually.
Yes, do tell.
So I was recruiting for my company, and I don't know, it was pretty cool. I'd been on campus before. Actually, I had been out to Boston a couple years ago.
Right, for the ESC.
Actually that, and also I had been out there for July 4th just to visit some friends.
Okay.
And so I had actually stood in front of MIT to watch fireworks over the Charles River, which is a great experience if anyone ever has the opportunity. Excuse me. But yeah, it's definitely different being on campus, and I was there both times when I think school was out, or the one time I was on MIT's campus, school was out. So yeah, big difference, but it's a great campus. Lots of smart kids and lots.
Who will work cheap, right?
I don't know.
That's the idea.
I don't know where you got that idea.
Admit, that's the idea.
It is still
why
MIT.
Companies go to head hunting at these campuses so that they can get talent cheap.
I don't know about that,
Dave. It's your first job. You work for anything,
These are MIT students, though.
You work for peanuts. Come on.
I wrote about it last night, actually. I wrote about, just the differences, because I didn't go to a top-tier school. I went to Case Western, which is here in Cleveland, actually.
Yep.
And, it's top 50. Whatever. It's not very high in that top 50
50? List. We don't even have 50 in Australia.
Well, there you go. Yeah, and Goodness. It's just the differences. The big difference is opportunity. It was I don't know. People could read the article, but it was a striking difference. They are clamoring for MIT talent, and I was one of the ones clamoring. So it was really interesting. I mean,
so this was a fair, was it? There were other job fair. There were other companies there. Who were the other companies? Were there other big?
Oh, yeah, big names there. I mean, Google snapping up talent like crazy.
Right, yeah.
The interesting thing was actually hardware. Hardware was not that big of a deal. Lots of software, lots of financial companies, which I've,
You were surprised by this? You sound surprised.
I'm a little surprised.
Come on, dude. This is reality.
Out of 350, there was maybe 20 employers looking for hardware, that made hardware.
I am not surprised at all.
No.
That's just the way the world works.
I guess that's just my naivete. So it was definitely interesting. There's a lot of financial companies there, a lot of people looking for...
Yeah,
and that,
we've talked about that before, haven't we?
Of course we have, yeah, and we're not big fans of that, and it's even tougher to see, because they can offer a lot of money. And, I can't really hold it against the students wanting to make money.
No.
But, yeah, it's just the market that it's in right now.
Yep. And if you're reading between the line there, if there's any students out there, read between the lines. Your job prospects are actually better if you're in hardware, because there's not as fewer people.
Oh yeah.
To actually compete against. And
I agree.
It's more niche. I reckon the hardware job prospects are very good.
And even more than that, I think we got so many people on the horizon getting ready to retire, maybe 10 years. It's gonna be a bloodbath trying to get talent in 10 years or so, and maybe all that talent will be in China, but I don't think all of it will be. So
no,
it's
not at all.
It's definitely interesting that more people aren't. But I mean, I've been saying that for a couple of years too. The world needs hardware designers, so even
I've
though
been saying it forever. There's always
you've
a
been saying it
job in
longer.
electronics.
Yeah.
You know?
Yeah.
Yeah, it might not pay as well, but there'll always be a job as long as
Right.
you know, as long. Well, you have to be good enough. They won't just take any dumb shit.
Right.
You know. Sorry to any dumb shits out there. I know. I'm sure we don't have dumb.
Oh,
shit.
the dumb shit
Amp our listeners.
population. No, I think our listeners are pretty smart. So,
And I get that question a lot in forums, various forums, not just the EV blog forum, and even personal email requests for help. You know, they always ask about their career. Oh, should I go into software or should I go into hardware? And I'm going, go into hardware.
well,
Because
really,
there's
the
just
answer
so
is
many people doing software.
learn both, but maybe specialize in hardware. I
Well,
mean,
you ultimately learn both anyway.
Yeah.
I don't think there's anyone who out there. I don't think there's a course these days where you don't do software in it. So
right. I agree.
really,
I agree.
even 20 years ago when I was doing it, you did a hell of a lot of software. So yeah,
Yeah, and you know, like the people there, it was I definitely put people up on a pedestal from MIT. I thought they were going to be very, you know, like brainy, and a lot of them were. I mean, they were very
Right.
smart people, but it wasn't as drastic as I thought it would be. Now, some of the stuff,
okay. You were expecting them to bring out Robbie the robots and
yeah, you know, that
all
kind
sorts of stuff.
yeah,
Right.
stereotypical
Yeah.
stuff. But I mean, they're still really bright kids, and
Yeah.
one I wanted to particularly point out, she was a sophomore, and she built a particle accelerator in high school.
Sweet.
It was amazing. I was just like, I mean, like that catches my attention no matter what. I mean,
Yeah,
and
that's just cool.
I'll post a link to their website from when they were
Oh,
developing.
you've got it. Okay, great.
Yeah, they're
Love
called
to see
the
it.
Cyclotron Kids.
Right. So did they do this off their own bat, or is there somebody, you know, behind there, some teacher behind it actually driving it and convinced them to do it and that sort of stuff?
I don't think so.
I'm
Well, I mean,
curious.
I'm sure there was a lot of mentoring support, but no. When I talked to her about it, she ended up teaming up with another student who she met
Right.
at physics camp. She said, and
Physics camp. What a bunch of funsters.
I mean,
All right.
I bet if you go through the roles of that camp, though, I bet they're all doing pretty well.
No, it's doing kick-ass stuff. Yeah, I know.
And so yeah,
No,
they
they're
were just
smarter than I am, I'm sure. So I won't bag them.
they were just really
Poking
interested
a bit
in
of
it.
fun at the
I know.
other sciences,
I know.
you know.
Oh yeah, I mean, yeah, we like even though we're nerds, right? We love the Big Bang Theory,
Yes,
and you know,
yes.
so
Oh, have you seen the latest Big Bang Theory episode?
yes,
The
I did.
latest, where he takes apart geology.
Yeah.
Geology's not a real science. we won't ruin the
Yeah.
the moment for you. It's good.
It's a great. It's a funny episode.
Or the rock people, as he calls them.
Yeah,
I love it.
I mean, that's the important thing is still making fun of yourself
of
along
course,
with
you
everyone else, right? I
Yeah,
mean, it's-
yeah, of course.
that's the
you have
best
to
part.
take the piss out of yourself.
yeah. There you go. There you go.
I'll take the piss out of myself at every opportunity. Everyone knows that.
And so you had the thing on here actually about nerd culture kind of thing, real quick, and
Oh God, this is going to be so bad.
so bad.
Oh, I got approached. It's not the first time. I've been approached via YouTube message, and I'll get to the eventual story, but here it is, right? So I get a YouTube message, which is probably the most unrespectful way to contact somebody, right? And
Yeah.
like when you get a personal YouTube message, it's like, oh, some dipshit doesn't know how to find my email address,
that's
right?
Or that's like
Yeah.
getting a piece of like actual spam mail in your
Spam
mailbox,
or something like that.
Right.
Yeah, exactly. So it lacks credibility, right? It lacks all credibility.
At the very least, yeah.
So I get a message saying, and the grammar was, it didn't introduce themselves, just said, "Hi, I'm a casting agent, and I'm looking for a nerd to be on this new nerd reality TV show or, something." And that was about it. Message me if you are interested or something, no other information. It's like, oh, piss off, So,
Yeah.
so I decided to play with this guy, and we sent a few messages back and forth. And I said, well, part of the intelligence test is trying to find my email address on my website. If you can pass that, I'll listen to you,
Yeah.
So he eventually figured it out. And,
Yay.
and he, apologies to him, he did turn out to be a legitimate person, and like he didn't have a legitimate website, didn't have a legitimate YouTube channel, nothing, right? So
So not a lot of that in Hollywood, huh?
I've had this before. I've had casting agents. Anyway, it turns out he's the head casting agent for a new reality TV show called King of the Nerds. And you may have seen this. It's made all the geek blogs and all this sort of stuff.
This is ridiculous.
It is ridiculous. And yes, it's as bad as it sounds. Basically, they've pulled no expense here. It's from the producers of Survivor, The Amazing Race, Mythbusters, right? So this is a big deal. Okay, and
maybe
but they've
I don't know.
Well, maybe, but they've you can guarantee a lot of money's going into it, right? It's not just going to make some cable channel or something, right? So,
right. Okay.
It is, a big thing, and they've got Lewis and Booger to host it. And if you don't know those names, then hang your head in shame and go and watch Revenge of the Nerds, please.
Yeah.
So, anyway, they've got Lewis and Booger to host the damn thing.
I can't believe that.
It's going to be tacky. And some of the stuff they're looking for. Tell us, Chris, what are they asking for?
Well, just all the stuff they smush all together, So they say nerd, which is a pretty generic term, right? But they're talking about gamers, comic book collectors, mathematics majors, physics and biology, people that are passionate about that.
Star Wars fans, Harry Potter fans.
Makers and DIY people.
Yeah.
People who go to Burning Man. I mean, where are they this is just such a
I don't even know what Burning Man is.
Oh, really? Yeah.
Yeah. What is Burning Man?
Oh, you had never heard of that?
No.
Basically, it's like an art and technology festival out in the desert. In Nevada. Yeah. And basically every year they have this huge effigy and they burn it, and it's like there's a big festival, but there's a lot of really kooky, cool stuff. But I would never put those people in with the people that are sitting in their basement playing video games. I mean, they could both be considered nerds, but this is just a ridiculous show. This is just the beginning of a horrible reality show.
Yeah.
So.
But they do actually mention Maker, and it says, "Are you Arduino proficient?"
Right.
Can you list all the digits of pi? Are you in Mensa? I mean, they've just pulled out every
ridiculous
stereotype they can.
Yeah.
And
it's for winning money too.
Freak?
So
maybe if you're one of the rock people.
Yeah. I don't know.
Boy.
It's gonna be an embarrassment. I'm sure it'll make the producers look worse than the people. Well, I'm sure the producers will make the people on the show look horrible. But
you're guaranteed to come out looking like a loser.
Right.
Yeah.
In terms of trying to promote the sciences and promote makers and promote, just like the STEM programs. This is basically the opposite of what you want to be doing.
Yeah.
Saying geek is the new cool. That's like that stupid when those stupid rock stars were on the first video, right? We talked about that in the past.
Here we go. Yeah, you're gonna have another dig at that.
Oh
right?
my god, it pissed me off so much. It was Justin Bieber saying, "Hey guys, I want you to know that I think what you guys do in science is just as cool as what we do in music." And first off, screw you, dude. We do stuff that's way cooler than you. And I'm gonna stop. Here.
Right.
So I don't think this is
a big fella.
Yeah, this is not a good thing for STEM and everything else. This is quite the opposite. So
yeah.
I will
Anyway,
not be
he tried to he loved my videos and he tried to convince me that I should join. And then I looked at it and I went, well, dude, read your own terms and conditions. Do I look under 30? I mean,
maybe you've just been aged by the Australian sun, huh?
If you read my About page, it says I've been in the industry 20 years. Yeah, I'm going to be 30 years old,
Yeah, maybe.
Fail. Anyway, so...
Yeah.
Anyway, if you're game and you want to win big, in quote marks, and you have no shame of looking like an absolute fool, which you will look like if you go on it, I guarantee it. But hey, if you want to get your head on telly, well, who am I to stop you? But there it is. It's nerdking.net. We'll put the link up if you're game and silly enough to try and enter something like this.
Yeah. All right.
But that would be cool if an Amp Hour listener actually got on there. We could...
I guess so.
It kind of would. Hey, everyone...
If
some
they mention
people
the
don't
show.
care. Some people might think, hey, that's my big break, And it could be. It could be a big break. If you're talented enough and you go on there and, you've got 10 million viewers each week or something, then you can make a big thing of yourself. So... I'm not necessarily going to say it's,
Yeah.
all that it's all bad.
It's not all bad, but it's not much good. How about that?
In terms of promoting, the sciences and
Yeah,
it's
I'm not
just
a big fan.
stereotype. I mean, it makes a funny movie, right? When you go and watch Revenge of the Nerds, if you haven't watched it, it's freaking hilarious. And it's great as a movie, but this is, they're trying to make it out. This is real, it's real reality, and they'll make you do these stupid contests. And I think I read somewhere that they were going to try and make the contests actually competitive. Like, you only compete in the area that you know. So if you're into Arduinos, like they're asking for here, if you're a hardware person, then, you don't have to compete against a Star Wars fan and answer Star Wars questions or something like that. So, I don't know. But, yeah. It's got tragic written all over it.
It's got dodgy written all over it for all those amp hour bingo people.
Right.
Yeah.
But no doubt there will be big dollars involved in the production of this thing. So
Yeah.
enter
Maybe.
at your own risk, folks.
Yeah.
That's enough of that.
Yeah.
I think
All
we've
right.
given enough promotion.
Let's get some shout outs here.
Shout-outs.
So first up, Gary Servin linked here. It looks like he just started a blog, half in Spanish, half in English. So I'll post the translated page. But yeah, great page, and he linked here, and we always like that, so we want to mention it on there. So thank you, Gary.
Yes. Thank you very much, Gary. Good luck with it.
Next up, our buddy John Oxer from Freetronics. I actually saw this from a Google alert I have set for the amp hour. I didn't know he posted this, but basically he's calling it a walk time vlog, even though vlog is one of the worst words in the dictionary.
Yeah, I'm not a fan of vlog.
Yeah.
Yeah.
But basically he's just kind of walking to work and brings a video camera with him, possibly on his phone, I'm not sure how, and kind of spews his mind onto camera. So it's pretty cool. And
Yes.
in his second installment, he takes up the chip fab at home debate, basically.
Oh, does he? I haven't seen the second one yet. Okay.
Oh, okay.
Is he
Yeah,
on my side or yours?
it's hard to tell. I think it's closer to my side, but depends on the our
Then he's wrong.
normal term of the debate. Basically, what he's saying is that it's a different game. So, like, Chip Fab at Home seems ridiculous now, but it's you can't compare it. So people should just go watch it. It's a really good discussion. And the thing I like best about it is that, and I encourage other people to do similar kind of responses too. It's tough because, Dave and I are always talking on here, and the way he says it is, it's like he's sitting in a room with us, listening to us talk, but he's in the corner tied up and his mouth is taped.
Right.
Yeah. And
Yeah.
so this is his way to express himself. I mean, obviously we love when people leave comments on the site, but that
Yeah.
kind of doesn't always do it justice. Sometimes
No,
people
you can't
really
do
want to
it
get a
real
rant.
time. You can't interact real time. So
Right.
Yeah.
And so that's I mean, it was a really well thought out, I thought. For someone walking to work, it was very well thought out. And
well,
yeah.
Johnny's very well spoken. If you've seen him on my their latest video, right at the end, we look
I
at
didn't know
some
that
of
was
the
him at the
products
end.
from Freetronics. Oh yeah, right at the end. And did
I
you
saw
know that?
I saw the chip. I saw the chip in there. I thought someone had just bought the Atmega 328 and put it into that board, but
right.
I didn't realize that was actually John. So
Yep.
yeah,
And,
that was a good video.
And he's actually got an RFID chip embedded in himself.
Really?
Yeah, if you've seen my video, you can't actually see it, but it's embedded in his arm. He's only one of, I think, 2 people in this country who've got an RFID chip embedded in themselves.
Wow.
He's got his whole house automated, and he explains some of this on on my latest blog. It's actually right at the end when I interview him and look at some of their Freetronics products.
Yeah.
Yeah, and he talks about, the RFID chip in his arm. So he doesn't carry keys or anything. He walks up to his front door, swipes his arm, and it... and he's in, So
That's crazy. I think
Yeah,
I
I
read
know,
about
it's
him
nuts.
planning to do that. I didn't realize he actually went
yeah,
through
he
with
was
it.
I think he was the first person in the country to get it.
Wow. And,
and
yeah,
he was-
I
He was
noted
telling
your-
me the story, actually,
Uh-huh.
of that. He actually had a surgeon all lined up to do it, and the surgeon said, yeah, I'll do it, because these RFID tags are... I think it's the same one that goes in, dogs and stuff, dogs and cats,
Okay.
these little chips. I don't know if you have that in the US where Or dogs
yeah, my
and
dogs,
cats must be
my dogs
microchipped?
have microchips, yep.
Okay, yep. So I think it's the same thing. So he had this surgeon all lined up, and then the morning of that it was going to happen, his surgeon called him up and said, sorry, but I talked to my lawyer and he said no effing way. Or, something like that. His insurance didn't cover it or something. So, yeah.
So it was a continuing battle, huh?
So he actually did it himself, apparently. So
oh, wow.
he went, screw that, I don't need a surgeon, and somehow did it himself. I didn't catch the rest of the story. I was going, I was too busy face planting,
Yeah,
face
right at that
point. No thanks. Yeah. I don't want to be
crazy.
microchipped.
I had actually,
Anyway, it's
I
kind of cool.
I put that video on the list this week because that you showed off the hackers, the people haven't seen Dave's video of the Melbourne Hackerspace, and so that's our ad hoc workbench of the week. They had you did a quick pan over the 23 minutes and 50 seconds I saw, so we'll list that as our workbench of the week.
Excellent, done. Yeah, it was good. I mean, that's as good as it gets as you can fit in somebody's garage.
It was nice. I mean, it was a really nice video.
And we had, I don't know how many people were there. It was, 25
like
people or something.
Oh, yeah, at least. Yeah.
There were a lot of people there. And,
yeah, definitely. We'll post a link about that. It was a good video. Yeah. I liked it.
So I hope they find a space. They've been searching for 2 years, and apparently they've been having quite a few problems trying to find one, but they're close. They're always close to, and they're actually, I was very impressed at the amount of effort they had gone to get one there. They're talking to government agencies and trying to get involved with various other big commercial groups and things like that. They're actually going to a lot of effort, and
it's trying to get stuff for free. It's tough,
yeah, I know, exactly.
Yeah.
So, actually, they were offered a space for free in a school lab or something like that, but the requirement of them using it was that they had to put everything away afterwards, so it had to be clean, perfectly clean, so that then the students could come in and use it as a proper as a proper science lab or something, So
right,
that's not going to happen.
Tinkering is not clean or
it's
tidy,
not. It's not conducive to the tidiness paradigm.
Right.
Yeah.
Right.
So they had to turn that one down, unfortunately.
Oh, that's too bad.
Oh boy. Anyway, yes, that was very cool. The Melbourne. So I've been to the Melbourne Hackerspace. Haven't even been to the Sydney one yet.
Well, that's next on your list, then, huh?
Yeah. Yep, it'll have to be. What else we got? Any more shout-outs?
No more shout-outs. What else? There's a whole host of things we can talk about this week. I mean, we've got chips.
We do have a chip of the week. There are lots of chips.
Yeah, lots of chips.
Lots of chip talk. Well, TI and TI are finally merged with
National
Semiconductor.
Yeah, they're gone.
I'd almost forgotten about that.
I know, right? Yeah.
Yeah, it's like
they're long gone. Sorry.
How long ago was that?
National
4
fans.
or 5 months?
Yeah, it's been. When the heck was that?
All right.
Yeah, probably 4 or 5 months. Something.
Have you
like
tried
that.
actually searching for a national partner? I was just searching last night. I think the websites are still separate and everything, right?
Yeah, they are. I found the press release on the national website, so national.com for people that don't know. It's all there. It's just there's a big header at the top now. And, you can still get all these parts. It's going to be a while until they start, merging product lines. And,
yes, and rationalizing their product line.
Yeah. Yeah, that could really hurt. That could really hurt me because I use some national parts that are like some really specialized parts.
Yeah,
and some really, really precise parts, and TI makes a lot of precise parts too.
They do. If there's any overlap, you can expect. You can expect a bit of a bloodbath there, I think.
Yeah, I hope not. It's interesting. I was actually asking for suggestions today, and someone wrote in. It was Niels Mosley. From Twitter, and he wrote in about it, and he actually asked, how do you select the right op amp because there's so many out there, and obviously that's a very open-ended question. But the thing is, if you look at it from the other side, when you already have an op amp and you have it in a system and it's a characterized system and all the little quirks and everything like that, if you have a national part in there, and then TI says, well, it's close, right? But it's a little bit off. If it's not exact, and it's never going to be exact, and it's not within the tolerance.
Phase margin's slightly different, so the damn thing oscillates, you know?
Yeah, some kind of thing like that. Yeah.
Yeah.
So at that point, you know, if you're trying to find the right op amp for the quote unquote right op amp for what you're, you know, already using it in an application, well, the right op amp is the op amp you already have. Otherwise,
is the one that you've thoroughly tested. That is the right op amp. Yeah.
Exactly. Yeah. And you know, if you're in a new application, then the right op amp is, well, depends. Right.
You usually have quite a bit of choice, you know. There's usually quite a few parts that could actually fit the bill. So it might come down to cost availability, you know, package type, package size, you know.
Yeah, I don't find that to be too restrictive. I find cost to be the main thing, because you can find just about, I mean, everybody makes the ones with their big bells and whistles, especially like the LTs and the TIs and the
LT
ADIs.
Are good at it. Yeah.
You know, they make these really great parts that are great on a lot of different bases, you know, like, but, you know, offset volt or input offset, bias current.
Yeah, but they cost, you know, $10, $20 a chip.
Even $5, that's a lot, you know. That was a learning curve I had when I was getting into, you know, when I started in a high-end field, and so then I went and tried to design something on the low end, and I'm like,
yeah, totally.
You know, if you can't put a $5 op amp in somewhere, so you really got to start making trade-offs. It's almost harder at the low end than it is at the high end, because, well, if you have a lot of money, you go to the distributor, or you go to your local, you know, rep, and you say, well, here's what I need, and they say, how many you need.
I've found exactly the same thing, and I've worked at both ends, the high end and the low end. I've got to admit, the high end is easier, because you just pick the highest spec part, and you know, who cares if it's $50 a chip? That's the chip I'm going to use, you know?
Yeah. The toughest part there is
down at the low end,
thumping on a vendor to try and get the part you really need. So maybe you have a bias current, you know, part with low bias current that you need, right? But you can't find anything with the right, you know, common mode rejection ratio or something like that. So then you have to try and go and encourage these chip makers to be like, this is what I really need, and then they have to actually say, this is also what other people need, and that's usually not the case, you know. Right. So yeah,
it's hard at the low end. I've probably done a blog on that. There's so many trade-offs, you know. Yeah. Trading off price, availability, package type, and and then and
then trying to make sure you don't miss the little things. That's when it gets really tough. You know, like if you run into like a voltage rail that you didn't realize that you don't have enough headroom or something. You know, like
exactly.
Problems out the wazoo. So to answer Neil's,
and sometimes you'll change your specs based on a part you can get. You know, you actually have a product spec, and you think it's fixed, but then you come down to it and you go, well, I'm not going to meet my price target with those specs. I'm going to it's either not make this product at all, or I've got to change my specs to meet this part I can get. Oh, you know, often you'll find a part and you'll go, oh, this part's great, it's available, there's 10 million of them, it's cheap, it's in the package I want, but its specs aren't that great, so you might have to re-engineer the circuit, change your specs, you know, things like that.
Yeah,
so
definitely.
That can come into it. There's so many trade-offs. Oh.
Yeah, so I think to answer Niels' question, how do you pick the right op amp? Carefully.
And speaking of choosing the right part, what about this microchip thing which you put on here today?
You know, I thought about you when I saw this. I saw this on Twitter today. Let me find the link real quick.
And you thought about me? Oh, how nice.
Yeah, I know. It's so sweet, isn't it? Yeah, basically it's an 8-bit micro though, and now so microchip has it's part of the PIC family. Yep. I'm not sure which one, but the
well, I'm looking at the brochure and it's part of the 10F family and the 16F family. So and the 12F. So 3 of their baseline kind of PIC families.
Yeah, but the big news is that they're putting reconfigurable logic inside of it, which is crazy.
Not just reconfigurable logic, but they're putting a complementary waveform generator and a programmable switch mode controller and a NCO as well. I've got a whole range of these new peripherals they're putting in these PIC micros.
Sounds like they're putting a kitchen sink in there, basically.
The kitchen sink. They're trying to up the ante big time. And as far as this configurable logic goes, it's a configurable logic cell, just like, an FPGA cell or something like that. And it has a flip flop in it. It's got it's got your gates, and you can configure it any way you want. It doesn't say how many are inside the chip though. I presume they only have like a couple. So don't get terribly excited that you're going to be able to get FPGA. So it's like an FPGA with 2 macro cells or something. That's basically what it is, I think. Although don't quote me on that. They might have 100, but I doubt it. I think this is just
it's for simple logic, right?
Yeah.
It's for simple logic, and then they'll have that other stuff in there for waveform gen and stuff like that. But...
Well, some of their example applications, they put data modulation, power sequencing, Manchester IRDA encoding, switch mode power supplies, event sequencing, yada, yada, yada. Boost buck regulator stuff, all that sort of thing. So, so even though you might only have a couple of macro cells in there, these are independent of the software. Well, they're tied in. You can tie them in to the peripherals inside your PIC, but they can effectively work, as separate outside of your source code. So it's cool.
That is cool.
Yeah.
Yeah, and I saw that they did PIC is known to have, real small 6-8 pin parts anyways, but it seems like this one, I saw it had 8 pins, it had FPGA style logic, and they're not necessarily FPGA in there.
It doesn't have FPGA density. Yep.
Right. And then 5-volt rails, and I remember though that you had said that in the past that was what you were really looking for. So
yep.
Yeah, that's what I was.
Unfortunately, it doesn't meet that, but hey, it's cool.
Yeah, it's a good start. Good start.
I like it. And there's a whole it's not just that, a whole bunch of other. It's got a complementary waveform generator and a complementary output generator and a numerically controlled oscillator, a 20-bit numerically controlled oscillator. Wow, and I'm not sure if they're all on the same chip. And it's got a programmable switch mode controller in there. And
the crazy thing is that this isn't even our chip of the week.
No, this is not our chip of the week, exactly. This is our family of the week, maybe.
I don't know.
But it's very... I don't know if you can actually get real parts. I guess they wouldn't announce this if you couldn't buy real parts, right? I don't think Microchip do the vaporware thing. So, I presume there's only, a few chips at the moment that would have this capability built in, but I like it. It's awesome.
Me too.
That's how micros have built themselves up. They started out, they were just a microcontroller with I/O ports and some internal memory, and that was it. Then they started adding, a serial port peripheral, like a UART peripheral and an ADC, and then, they're building up, and now they've got, as you said, the kitchen sink almost.
Yeah, there's everything in there.
Which is great, and that's the advantage of micros, is that they have all this stuff built in. And that's the disadvantage of FPGAs, is that they don't have this stuff built in. You have to define it all in the hardware, and it's just isn't as easy to use, really. But as we've probably mentioned on here as well, the FPGAs are now starting to have what's called hard silicon, which has a lot of all these functionalities actually encoded as a hard silicon block inside the FPGA, so you can use it more like it's being used here inside a micro. So they're trying to jump on the same bandwagon.
It's almost like they're all going to converge eventually. Just kind of dive down into the same area.
Micro, but
they're all trying to cover as much space as possible. Chip makers don't want to make something that one person's going to buy, and then they're like, oh, well, sorry, no one else is buying this. So they want to try and cover as much space as possible. And
But as always, FPGAs won't match micro, like a hard silicon solution. That's why they're embedding hard silicon solutions in them, is because they can't meet the price point, they can't meet the power consumption, the speed, all that sort of stuff. So
I'd give you on the power and the speed, but I don't know, with an 8-bit micro, I guess that's price point.
It's a price point thing, you can...
From a perspective of processing power, you can start to match that kind of thing with an 8-bit.
Yes, you can inside your FPGA, yeah, you can have a hell of a micro, but it's not like you can have a 1 gig ARM processor inside an FPGA. You're just not going to be able to get that. It's just not fast enough, So, yeah, that's just the way it is. You can't beat an actual, a laid out silicon. You can't beat properly laid out silicon in terms of speed and power. It's just not doable. So, once you get to a certain level. But yes, everyone knows inside an FPGA you can stick an 8-bit soft core in there and it works a treat,
Right.
Up to 50 meg or something.
In the spirit of not beating silicon, let's get to we've already mentioned this once on the show today already, but there's actually a decent article, I have to say, about printed electronics. Now, I know.
Dude.
I know. But this is actually a guy, so he's got printable organic electronics, okay? He's from some Linköping University in Sweden. His name's
Swedes?
Lars.
Wow, I don't think we've had the Swedes on the Amp Hour before.
Right. They're giving me a run for my money on my pronunciation.
Oh, they've got great names, yeah.
Lars Herlogson. Anyways, he's able to get down to a 100 nanometer gate with conventional printing techniques.
Yep.
Basically, he's using an electrolyte and he's using a polymer, and he's printing organic transistors in complementary N and P types.
Awesome.
Yeah.
And as I said, it's possible. Of course it is
possible.
People are doing it. But it ain't going to be a revolution, dude.
It's awesome. Yeah. Yeah, okay, well, I think this is moving us closer. So he says, let's see, the supply voltages supply voltages, they operate down to 0.2 volts, and they have static power consumption of 2.5 nanowatts per gate. It's crazy. And they can switch at about 0.2. I guess switching time's a big deal too when you're doing organic stuff, because it's a lot slower. You don't get as much charge injection into the gate. You can't switch as fast, but it seems like they're switching pretty fast in this thing too. So I don't know. I'll post a link to this guy's paper. It was like a a master's PhD type thesis. And,
yes, it is a PhD thesis.
Yeah. So I don't know, and he's going into industry too. I mean, he says, what else? He's working at some thin film company out there in Linköping.
Linköping. Excellent.
Yeah.
Oh,
I don't know, man. I think it's getting better. It's getting better.
Of course it's getting better. I've never said it wasn't.
All right, well.
Dude, even if you get your damn printing machine that does it, it's pointless.
I don't think so. Dave.
Oh, man. Okay, just try and package it, dude.
Okay.
Try and test it. Try and characterize it. And you'll find that buying your 50-cent micro from DigiKey is just a hell of a lot easier. And you got 100,000 to choose from.
Yeah, your 8-bit micro with reconfigurable logic. Yeah.
You're just going to... it's just not going to happen. Next.
You know what? John Oxer agrees with me. Yeah. Anyway, okay.
I agree with you on certain things, but it being a bloody revolution and people will print their shit out instead of buying their chips is absolute bullshit. Always has been, always will be. You're just not thinking fourth dimensionally. You're not thinking practically. Bit of a Back to the Future joke there.
Fourth dimensionally? I like that. Yeah.
Fourth dimensionally, yep.
Right.
Had to throw
Marty!
You got to come back with me. Back where? Back to the Future. Sorry, I could recite the entire movie, but I won't.
Oh, okay, that's good. Let's not do that.
All right.
Well, then how about we ground ourselves back in reality and get back to Chip of the Week, because I kind of stepped away from that. So this was your Chip of the Week. You picked this one up.
Oh, right. My Chip of the Week. Okay, let me call it up. All right. Oh, you don't have the real-time music.
I don't have the music, no.
No. All right. The Chip of the Week is the Linear Technology again. They've been on here before, haven't they?
These guys. These friggin' guys.
Anyway, the Linear Technology LT1512 or 1512. I like calling it 15, double digits kind of.
Yeah.
So how would you pronounce it? Would it be the LT1512? Or would it be
I'd say 1512.
1512, so would I.
Yeah.
Yeah.
Okay.
Anyway,
right,
it's
so what do
the
we got?
LT15. It's a it is a nothing special. It is a lithium-ion battery
it's actually not
charger.
that great, I gotta say,
It's
yeah.
actually a multi-chemistry, right? But I'll explain why I think it's kind of neat, because I was looking for this the other day. I'm actually going to use this chip, I think. Okay? I was searching for it last night, and for a thing I'm working on. And
For a thing, a thing with a guy.
a thing with the guy. With
Thing with a guy.
Yeah.
The thing with the guy at the time. Yeah.
Yeah, that's it. Everyone knows that. Yeah.
Right.
And I was searching for a lithium-ion battery charger IC in a dip package, right? And there's not that many, okay? Because they've all moved to these tiny little...
Yeah, because who uses dip packages
Exactly.
anymore, right?
Who uses dip pack? Well, this was going to be for a kit, right? So I thought, okay, I wanted to keep everything dipped for just old time's sake, right?
Okay.
So
okay.
I thought, and I was looking for it. And not only is it dip, but it's an 8-pin dip as well, okay? And it's a lithium-ion. Actually, it's multi-chemistry, okay? So it can do lithium-ion as well as NiCad and nickel metal hydride and lead acid. And it's it's got the constant voltage, constant current mode thing. So it's able to do lithium-ion batteries. But it's a CPIC converter, or SEPIC, however you want to pronounce
I
it.
say SEPIC usually, yeah.
Yeah, SEPIC. SEPIC converter, which means that, if you're not aware of those, it means that it can charge the battery from not only above, with an input voltage above the battery voltage, as a normal linear mode converter works. So that's how most lithium-ion chargers work. You need an input voltage greater than your cell voltage that you're trying to charge, because they're just a linear pass element and, that sort of stuff. But this is with a SEPIC converter, it can be equal to or lower than the input voltage. So it can actually go up and down. The
that's
input
crazy.
can go any range, and it will still charge your battery. It's brilliant. I love it. And it's
like
in
a
an
universal input almost,
Yeah.
It's
Yeah,
not,
it's
not
like a
really. I don't want
universal
people to
input.
think
Yep.
you could put like AC into it, like AC mains into it or something,
Yep.
but, it's very forgiving,
Yes,
It's,
yes, it is. And that's the joy of the SEPIC converters. They're just excellent. And
So now do you take a hit on efficiency when you do that kind of thing because you are dropping more?
yes, it's complex, but it's not the most efficient converter out there. If you're going for ultra efficiency, then you wouldn't bother. But but SEPIC converters are really nice. Like if you're powering, say, a 3.3 volt circuit, right, and you want to power it from a single lithium-ion cell, this isn't just for charging. You can use this as a DC to DC converter to power your circuitry, these SEPIC converters. But a lithium-ion battery at full voltage will be around about 4.2 volts, right, and it will cut out around about 3 volts. So that goes from above your 3.3 volt rail you want to below your 3.3 volt rail. So if you want to power your 3.3 volt circuit from one lithium-ion battery over the full operational range and extract the maximum capacity from your battery, this is the way to do it. Use a SEPIC converter.
And that's the difference between using just a buck, where you have to, if you're doing that same 4.3 down to 3, then you have that whole 1.3 volts to drop, and then you have
and
more
then
voltage to drop at the top. And
Yeah, so you got to use one or the other, and you can use a buck. You can use a buck boost converter as well. But SEPICs are really nice. And if you don't know what it's, SEPIC is a single-ended primary inductor converter. That's it. And it's neat. It's a neat solution. Anyway, I thought this chip was really kind of cool because it's available. You can buy it from DigiKey. It's an 8-pin dip, and it's a multi-chemistry, and it's a universal input range. Oh, what more do you want? It's brilliant.
It to be 1 penny, to be cheap.
A penny. Oh, sorry. Well, no, it's not that cheap. It's like $3 or something,
Yeah,
So,
yeah. That's interesting, though. And they probably get away with that with low drop die. Yeah, that's kind of like it. I kind of struggle with like switchers because I know they're so crucial and they're kind of part of this whole like energy, green power friendly revolution, right? It's a really big thing, and like all of these companies are getting into it. Like the biggest chip players, it's a very large part of their market. They all have a very big chunk of the market even. But sometimes I just find myself going, this stuff's kind of boring. You know,
Right.
I don't want to say that because they're really complicated internally. I mean, like they're essentially small control systems inside. You know,
Oh, yeah. And the theory behind them.
Yeah, exactly. You're drawing off a little bit of current and, going across the sense resistor, feeding that back through. That's your information that actually then changes your drive circuitry and switches your PWM and everything else that's
and
crazy
then you can
inside of it.
switch into different modes depending on what part of the cycle you're at, and they can skip. You can skip pulses, and you can do,
Yeah, exactly.
It gets pretty advanced.
It's very advanced. And then there's even just the physical side of it, like knowing like power dissipation, this packaging. All these vendors are trying different packaging types. Like, I know LT does like that land grid stuff where they actually sync into the board. But man, like,
and then there's switching losses, board layout losses, and all sorts of,
And I know I'm supposed to like it because I like analog stuff.
Yeah, right.
But man,
well, what's wrong with you?
It's just boring sometimes. I mean, part of me, this is just me being honest, part of me says power is just supposed to work. I know it doesn't. That's actually one.
Yep.
It's a very big misconception, right? But that's what I want.
well, that's it. I was working on my design last night, and I was putting all this effort into charging my bloody lithium-ion battery, and I thought, it shouldn't be this hard, I
know. And yet at the same time, that's one of the most potentially dangerous things because lithium ions can blow up in your face,
that's
right?
That's right. Exactly.
That's bad. That's real bad.
That can ruin your day.
Yeah.
Oh, boy.
But, yeah.
Yeah, well, a lot of people will avoid that. If you're working on low volume stuff, you will just whack in a DC to DC converter brick that's already... It's already done for you, Yeah, it'll cost you $30-$40 or something, but who cares? It saves you a week of design time.
Yep, exactly. Yeah, getting that money out in one of these is like really it's pretty tough.
Right.
Yeah. Well, that's a good part though. That's a good pick, Dave. I like it. I'm sure. Right. I'm sure our listeners will like it as well.
Very good.
One thing I wanted to point out in the same energy vein, I saw an article today about a 50 millivolt drop diode. So it's actually, and it's actually it can pass 20 amps. So forward biased, it can pass 20 amps with a 50 millivolt drop. So what is that? That's like 0.1 volts.
What?
Or 0.1 watt rather.
What manufacturing process does it use to get this sort of stuff?
I have no idea.
It's got to use something exotic, right?
I think... I don't know how it works. Basically, I was fixated on the 50 millivolt drop. I mean, there's a lot of focus on this. I was talking to someone the other day about doing their master's thesis about, trying to work on lower and lower drops because, you really start to lose efficiency there. But, man, 50 millivolts, that's crazy.
Yeah.
So... I'm not sure. I have no idea how they did it. I'm not sure if it was, just straight silicon with crazy doping, or if they went to like some more exotic topologies. But this is meant for like solar operations. So
they're talking about solar panels and stuff like that. So
so you do need to pass a lot of power still, but I don't know. Yeah, so that was my little fun thing I saw. I don't know.
All right, done. What is that? That's not really a chip of the week. It's sort of a technology of the week, is it?
Yeah, I guess so. But I don't even know how the technology works.
Well, that's a fail around. If you're going to put it in here, do your research.
Oh, yeah, do my research, huh?
Right, yeah, as if we research anything on this show, right?
Well, speaking of something else I didn't research, this is actually something someone told me about. I didn't realize there was an open source logic analyzer out there. Have you ever heard about that?
I believe there's more than one. I think there's...
Oh, really?
Yeah,
okay.
Yeah, I've heard of a couple of them, I'm sure.
Okay, so this one's called the SUMP, or sump.org, and then it's some kind of analyzer. I was talking to someone about this at that career fair I was at, and they mentioned it, and
it's analyzer with a Z, with an American Z.
What, do you spell with an S?
S, yeah.
Really?
Yes,
that's
we do. Yeah, we spell analyzer with an S. Yep. In fact, that's one of the big bugbears when you're actually working on Australian stuff, and spell checkers all have Z. If they're American based, they will actually change all of your S's to Z's. It's really annoying. It's actually a big deal here. So
yeah,
it's pain in the ass.
It's like a pain point for you guys.
Oh, huge. Because we have a lot of words where you guys use a Z and we use an S. There's a whole bunch of them. Analyzer's just one of them. Sure, there's many dozens.
So do you pronounce it different?
No, same.
Analyzer?
Oh, analyzer. No, we don't say analyze. Well, I can't even pronounce it. No, we actually say it the same. We say it as almost a Z-like, I think. But
yeah.
Anyway, there you go.
Anyways, yeah. So I had never heard of. I mean, I hadn't heard about this. It's basically just using a starter kit, actually. So like a Spartan 3 starter kit.
Yep.
So off the shelf kind of kit you can buy, and
there's a problem with that though. Using starter kits, they're not a long-lived product. They just do like a batch of them. They manufacture, 5,000 of them, and then they don't manufacture them again. So basing. There's the Amp Hour tip of the week. Tip of the week. Is that a new segment?
Blank of the week, yeah. That should go on the
try
the Amp
not
Hour
to
bingo.
use one of
Blank
these
of the week.
manufacturer development boards as a platform for any sort of project you're working on, because you won't be able to buy it in a year's time. I guarantee it.
And that means it's not open source either, right? I mean, like, well,
probably not. I don't know. But even if it is open source, it's a pain in the ass, because then you'd have to go out and manufacture it yourself. The whole idea of using a manufacturer's development board is people can just buy it,
Yeah.
So, anyway. It's
well,
a pain.
I guess I didn't. I don't know. I thought it mostly looks like it mostly is a software interface. So maybe that's what the person was talking about.
I'm sure it is. Yeah.
The open source side of things, but it seems. I mean, if it can actually do what it says 16 channels at 200 megahertz. That's not too bad. I mean, it's not.
Yeah, that's pretty
not
good.
blazing fast, but that's not too bad. So
well,
I agree with you though.
But state it can only do up to 50 megahertz. So using an external clock. So but still, that's that's decent.
Yeah.
So.
Yeah,
because with the logic analyzer, there's state analysis mode and there's timing mode, and timing mode is almost always capable of a faster speed than state mode. So, yeah, it depends on which
it's
state mode.
Clocked,
it's an internal free-running clock, whereas state mode uses an external clock from your system under test, so your logic analyzer is synchronized to your circuit under test, and that's usually for various reasons at a slower rate than timing mode, which is a free-running clock. So
I didn't know that. You see, that's the thing. I've only used logic analyzer. I just hook them up and go. So I don't know.
Trap for Young Play. Well, I had a logic analyzer project. It was published back in 2000 and no, sorry, not 2000. God, 1994 or something. It was published, I think.
Same thing, right? A whole great bunch of years ago.
Yeah, a long time ago in a galaxy far, far away, I had a logic analyzer design published. And once again, it was open,
Yeah?
Yeah. It's,
so, do you have a link to that? Is that up on your old
it's up on
site?
one of my old sites, yeah.
We'll have to try and find a link to that.
And it used a lattice semiconductor CPLD. It didn't use an FPGA. It used a CPLD. So
good luck finding one of those these days, huh?
Well, yeah, exactly. And
they're still making CPLDs,
that thing out, and I actually designed. I fitted it all by hand, right? Because I didn't use a high level description language like VHDL or Verilog. I actually went in there and did it at the gate level, and I actually placed I placed the individual gates in the individual quadrants of the chip, and I got 100% routability on this thing. I used every pin, I used every logic cell, and it just fitted. And that's something you can't do if you leave it up to the computer to figure out where to put stuff, right? So I hand laid out this CPLD, and I was actually quite, chuffed that I got 100% routability in this device. And they claim you couldn't get 100, you might be able to achieve 95% routability or something in these chips. But no, if you do it yourself and you're clever, you can actually get 100% routability. I was quite proud of that. Anyway, that's
pretty great.
Side thing. Yeah.
Yeah, today to get that kind of thing, you basically have a law of diminishing returns usually as you get up 97, 98, 99% of the usable logic in a device. They say, like you said, they say it's possible, but not really.
No, when you try and actually, there's a lot of overhead.
Right?
Yeah. Exactly. So there you go. Did we learn something today, Chris? You learned
I
that
did.
state analysis and logic and timing analysis on Logic Analyzer. If you looked at my Logic Analyzer tutorial I've got up there, there's a video. It goes for like an hour or
I
something.
read through everything else except that, Dave.
Right, okay.
I read through your crazy-ass, nerdy dating site book, whatever the hell that was. I'm kidding, I haven't read that. No.
I've got a lot of content out there. Well,
Yeah,
you don't
do.
need to now, right? You're hitched.
No, I am hitched. Yep.
Yep.
Just
Has
like
she
last
started
week.
to leave that thumbprint on your forehead yet?
No, not yet.
No? It'll happen.
All right.
Yep.
I'm telling on you. I'm telling your wife.
Right. You dobber.
Yeah, right.
Yeah. Oh, boy. Anyway.
So one last thing I wanted to mention before we're up. Well, I don't know. Maybe we can get the This Week in Nerd History too. But I don't know if you saw the Hackaday link. There was a link. They linked over to ProtoStack, and
Yes.
ProtoStack had this pretty cool little tutorial. It was like 8 tips on how to use breadboarding. Like different breadboarding tips.
Yep.
I thought those were pretty
Okay.
cool.
I haven't seen it.
one
I've
was
actually
like-
got a ProtoStack here. He sent it to me a long time ago. In fact, is he Australian? I think he might be, or am I mistaken? Sorry.
I'm not sure.
Um,
I'm not sure.
And I forget his name too. So sorry, but yeah, he sent me a ProtoStack, and they're not bad little boards.
Yeah.
Yes, Forest Lake in Queensland. Yes, Australian. There you go, ProtoStack.
Nice.
Protostack.com. And they make little prototyping boards, and they're quite neat. I like
Yeah.
it.
I like the so what number 6 on their little list. They actually soldered some gold 100 mil spaced headers, like conversion headers, to a SD card, and then they plugged that directly into a breadboard, so you could just break out the pins.
I see it. Oh, that's sweet. You can plug an SD card into your breadboard.
Yeah, I
It's
thought
the
that
same
was really
pin
clever.
spacing, is it? It's almost looks like
I guess so. It might be a little off, but
a
it
little
looks,
off, but it fits. Hey,
Yeah,
that is
and,
neat. I like that.
I thought that was a really really cool idea, and they call it ghetto. I remember you were a little weirded out by that word the first time I said it. But,
Ghetto.
Ghetto, yeah, ghetto
Yeah,
micro deslatse. I think that's what he was saying. Ghetto, right?
Ghetto is a slum area, right? It's a low rent.
Right, but it also means like jumbled together kind of thing, or
Right, okay.
low budget kind of thing.
Yeah,
that
yeah.
would be the idea.
Right.
Yeah,
That is neat. I like that.
yeah.
I'm impressed.
I like that too.
That's it. Yeah. Okay. We'll definitely have to put that one up as a link. That is a great little thing. Yeah, I'm amazed at the things people are pushing into breadboards these days. They push all these big
I am
fat
too.
pins in there, and people, there are specs on the
Breadboards are
size
not-
of wire.
Well, I was just gonna say the signal integrity. I mean, you run out of room real fast.
Well, no, but if the spring contacts inside, it pushes them apart and it forces them apart. If you try and push a big square 0.1 inch header into the breadboard, it's not designed for that, and you're just going to bust the thing. So anyway,
Yeah.
I get peeved off that these days. People sort of. Yeah, I see all these
I think
photos
it's a
of all
good
these
trade-off,
hacks,
though.
and people have
Yeah.
shoved all these things into the breadboard. I cringe every time I see it.
I know,
Sorry.
but it's a good trade off to get more if it gets more people involved.
Oh, of course, yeah.
If that works them into soldering and everything else, then that is a good thing. So I'm okay with that. And yeah, a couple breadboards get ruined, but whatever.
Yeah, okay. Well, yeah,
They're
fair
pretty
call.
cheap these
I've
days.
got like 4 breadboards or something, so yeah, it doesn't matter.
Yeah.
Right. Oh, boy.
All right, how about we close out with some nerd history today?
Do it.
All right, so today in history, in September of 1922, so this is actually the 27th. We play games sometimes because it's technically the 27th in Australia. It's only the 26th here, but really nothing on the 26th happened fun in history.
Okay.
At least nothing electronics related. So in 1922, though, basically it was the first time that they ever proved out radar, and it was a guy, Dr. Albert Taylor and Leo Young, and basically I think they were just playing with RF stuff, and they plane
Yep.
flew by and they experienced interference, and they're like, hey, we could use that.
Brilliant.
This is a good idea, and it didn't get commercialized till much later, but
Yep.
they were doing experiments, and yeah.
Well,
and
it
they saw
all
interference.
the research happened all the main research happened during the war, right? Or was
Right,
it
that's
just
when they
before
really
the
ramped it
war?
up.
Yeah, exactly.
They really ramped it up, and I think
Yep.
45 was when I think the British started using it in a actual capacity of you know,
Yep.
trying to see if planes are coming. But
Well, they had it at didn't they have radar at Pearl Harbor? They had just installed one and they were
Yeah,
using
something like
it and
that.
they didn't see it or something. 'Cause
I'm not
somebody
a big history
was,
buff.
you know,
Yeah.
yeah. I'm
It's
fairly
int-
sure they did. They had something
Yeah.
operational then, some crude system, and I think it did work. It saw the Japs coming, but there you go. Is there
Hmm.
a bingo square for war stuff?
No, I don't think
No?
there's a war one yet.
All
no.
right.
It was interesting though, reading about the second guy, Leo Young. He it talks about him and like using spark gaps. So just like how they used to do radio transmissions
Yeah.
was I never knew about that. You know, basically you charge up an antenna and then you have a spark gap and that determines how much voltage you
Yep.
need to jump across. And then every time it jumps across, that's actually when it's shooting, you know,
Yep.
RF into the air. And I was reading that, and I just immediately thought, "My God, they must have been just like blasting themselves with radiation." You know, that's how they make X-rays these days, isn't it? I mean, like you like spark a gap at a really high voltage, and you start radiating energy. So, I mean, yeah, you get a radio wave, but you also get, you know,
Yeah.
a nice little shot to the gut of X-ray. Maybe I'm wrong about that. I
A
don't
few
know.
100 volts per meter or something. You know, you.
Yeah, I
Yeah.
thought that's really bad for people. I was thinking that'd be fun to try and build though, like these days, if you could shield yourself, you know, like wear some lead underpants or something like
Faraday,
that.
Faraday
Yeah.
cage or something.
Faraday shorts, right?
Right. Tinfoil hat. Don't forget your
There you go,
tinfoil
tinfoil
hat.
hat. Yep.
Oh, brilliant. All right.
Well, I think that's it though. I don't know if your stopwatch is still going.
Yeah, our time's up. Sorry.
Is it?
Yeah, I think we've gone over.
Okay.
Bummer.
Well, not too far. We didn't go over too far today.
I
So-
wonder if anyone got bingo.
I hope so. Let us know in the comments. You know, let us know in the comments anything, really. Our comment section has been kind of bare lately. I don't know if people haven't had much to say or we haven't been saying stuff that have been piquing people's interest. But, you know, if you got comments, leave them there. If you want to hit us on Twitter, you can check out our Twitter accounts. I'm Chris_Gamble and Dave's EEV blog. And
And of course, Chris is obsessed with Twitter, so please tweet him. It's his
Stop,
life.
please. It's not my
You were
life.
tweeting on your wedding day or something. Come on.
I was writing an article on my
No,
wedding
you were
day.
writing a blog article on your bloody wedding day.
Yeah. Yeah, and it was really popular. And you know what? Yeah, take that.
Right.
I
Sorry,
didn't write
but
it
you're
during
still
the
a
ceremony. I'm fine. It was like 10 in the morning. I was watching cartoons. It was fine.
nerd. I think you need to go on that King of the Nerd. You're under 30. You can go on this King of the Nerds.
I'm not going on a date.
reality
No.
show. Come on.
No, I'm not doing it. I'm sorry.
Please, if you want Chris to go on, comment,
Yeah, let us-
tweet him.
let us
Chris
know, yeah.
must go on King of the Nerds so we can make
Yeah.
fun of him on television.
There you go.
That'd be brilliant.
Yeah. All right, guys. Well, we will talk to you next week. More electronic nerdiness, and maybe Dave will have convinced me by then.
Right. All right.
We'll see you.
See you guys.